we've got a mixture made with 3 different compounds here, and in the end we're going to get 19.2 liters of this mixture. So we want to find the molar mass of this thing and what gas it is based off of this information. Well, one thing we should know is that at STP, for any mole of gas, we have 1 mole of a gas. That's going to give us 22.4 liters. It's a conversion factor we can use. So let's just go ahead and figure out how many moles of this gas we really have by, essentially we're just going to divide this by 22.4. So let's go ahead and do that. 19.2 divided by 22.4 will give us 6/7 moles of this, which is 0.86 or something. So we have this mixture, and we have almost a mole of that mixture. Now, let's try to break these apart into different components. We want to figure out how many moles of this thing we have so that we can figure out the molar mass. We know the grams. So if we want to figure out the number of moles here, we got to figure out the moles of this and the moles of that, and then we could subtract everything, and we'll figure out the moles. So for argon, all we need to do is take our 8.1 grams. So let's go ahead and divide that by the molar mass of argon, which should be 39.948. So we basically get like 0.2 moles of the argon, which I'll leave in a fraction form, just for a little bit more precision. So that's how many moles of argon we have. And then for the neon, we'll do the same thing. 8.1 divided by the 20.18. So we get like 0.4 moles of that stuff, which is 405/1009 moles of neon. And now we can basically just say, let's subtract 6/7 here. We're going to subtract all the other stuff. 3329, subtract 405/109. And we basically finish off with a certain number of moles of X2, like 0.253 moles of this X2 gas. And we should be able to like try to convert this. If we had 1 mole of this X2 gas and we want to know what is the molar mass, then that should finally give us in grams there, then that should give us an answer in grams of 8.1 grams of this stuff, right? Let's get rid of this 1 on the bottom. This is kind of a bit useless. We're trying to solve for this, so let's go ahead and divide 253 X2 on that side, so we figure out what that unknown is. So we're going to do 8.1 divided by our answer, and we should get that the molar mass is going to be equal to 32.02 grams per mole. And if we look on the periodic table, we should divide this by 2. Looks like it's 16 grams. Oxygen is going to have 16 grams per mole, rounded. So it should be O2 gas.